Hi guys, I'm Jonas.
I'm Mason,
And I'm Dermot.
and today we are going to be doing a water model project.
This project will consist of molecular motion, phases of matter, phase change, temperature, pressure, and density.
Let's get straight into it.
Density is the weight of a substance for a specific volume. So we're going to take some salt, we're going to pour it in this cup, a lot of salt, about 4 cups, tablespoons. We're going to put the egg in the salt water and see what happens.
First, we're going to do the clear water. See, as it just sinks to the bottom.
And then you take the egg back out and you put it into the salt
But when
water.
you put it in the salt water, it floats.
That's
Density.
density.
And we put the salt in to help show the density because salt makes water more dense, like the ocean.
By putting ice inside water because it's less dense than water. So
Ice
it
is more
floats.
dense. Ice is less dense than water, so that means it floats.
Now we are going to be showing phases of matter. First off,
This is a liquid. This is a solid.
and this is a gas, as you see, is steam.
Now I'm going to be showing phase change. This is phase change from a liquid to a solid. As you can see, this water has been sitting out in the open for about an hour and hasn't changed at all. But when you put this inside a freezer, all of the condensation, it went on the sides of the glass and ice started to form inside the glass to show phase change.
Now I'm going to show a phase change from solid to liquid. As you can see, we have a bowl of ice that has been sitting out for quite a bit, and not all the ice, but most of it has melted. So this is an example of a phase change turning from, it was first a solid and now a liquid.
This is a phase change from liquid to gas because we are now boiling the liquid and it's turning into steam or gas. And this is the phase change of liquid to gas.
Now we're going to show temperature. As you can see, right now it's 15.8 degrees Celsius in the room.
Temperature.
But then when you put it inside freezing cold water,
And ice.
you can see that it's dropping the temperature. Well, you can't really see it, but
This is a great way to show temperature change. And now it is 1.0. Now it is
Celsius.
0.9 Celsius. And as you see,
Right here we have a glass of cold water and a glass of hot water. And we're going to pour Kool-Aid liquid into the cold and hot, and we're going to see which one
Has the most molecular motion.
which one spreads the fastest, because that's going to show molecular motion. So first do the cold one, and then do the hot one.
And you can see
and
that
now
the
we
hot
see
one
that the
has.
hot one is already full, and that one is still going really slow.
It's not full yet, but you can see the hot one's winning. Especially because it's wider, and this one's not as wide.
But this one went way faster than the cold one.
And the cold one started late. And the cold one started first. And as you can see, it's already rising up, and this has barely. You can see maybe a little bit rising up, because when water's hot, it's always the molecules are always going faster, and if the water's cold, it's more slowed down. Now we are going to be showing temperature, pressure using this Kool-Aid bottle. This Kool-Aid, this candle, and glass bottle.
As you can see, when you put this on, the liquid rises because the temperature change allows the pressure to change and the Kool-Aid to rise up. And you might be able to see that it keeps rising a little more every second.
And we're using Kool-Aid to make it more visible, so you can see it better. And now it's picking up a little.
It's getting bigger.
Yeah, and going faster. Now it's slowed down.
Thanks for watching, guys.
Once again, I'm Mason.
I'm Jonas.
And I'm Dermot.